Modern commercial jetliners have compiled the best reliability record in aviation history. But it took many years to learn how to develop this reliability. Experience has demonstrated many times over that the number of engines does not measure an airplane's reliability. More engines could not overcome the systems deficiencies of early long-range transports. Advances in power plant and systems technology greatly improved airplane reliability during the 1940s. But by the 1950s, the piston engine had reached its limits. There was no arguing with the statistics. The more horsepower a piston engine was required to produce, the greater the risk of failure. This risk prompted a new regulation in 1953, requiring commercial twin-engine airliners to be within 60 minutes flying time of a suitable airport at all times. This piston-era 60-minute rule is still in effect. In the mid-1980s, in recognition of the reliability of the modern turbofan engine and the airplanes it powered, the world's regulatory agencies began granting exceptions to fly twin jets farther than 60 minutes from a suitable airport. Known as Etops, extended range twin-engine operations, these exceptions allowed qualified operators to fly first up to 90 minutes and then 120 minutes from a suitable airport. As airline experience and airplane reliability continued to climb, approval was granted for Etops flights up to 180 minutes from a suitable airport. By the end of March 1995, more than 75 airlines had received Etops approval, and more than 11,000 Etops flights were being conducted each month. Etops has proven to be a routine, safe, and highly successful way to conduct flight operations.
Etops now has become very routine. This, of course, because of advances in engine technology, in system technology, and the very large amount of experience that has now been generated has given people that confidence that it's a routine, matter-of-fact flight, quite frankly.
Etops approval brings with it a number of benefits. Twin-engine airplanes give airlines the flexibility to offer non-stop service between a greater number of cities. Equally significant are the benefits to the traveling public, a greater frequency of flights, and reduced travel time.
For flexibility, it allows us to serve some of those routes that are what we know as thin routes, perhaps a 200, 250 passenger route, where previously we would have a 747 perhaps 3 or 4 times a week. We can now have a 767 daily, which of course is very good to everybody that would want to travel on those routes.
Airlines soon discovered that Etops not only provides a multitude of benefits on their existing routes, it allows them to explore the potential of new routes.
What it basically says that if you're trying to get into a new market and you have to be able to get into the new market, you need to have Etops capability, because you can enter that market efficiently with a relatively small airplane if you need to, and as the market expands, you can either increase the frequency of service, which is great for the customer, or if the service gets beyond the capability seating-wise of the airplane, you can bring a larger airplane in. Just lets you go more places. It's totally consistent with a global strategy, and everyone knows we live in a global economy, and you have to react globally, strategically.
Etops allows an airline to fly the most direct routes possible. The 60-minute rule often forces an operator to deviate hundreds of miles from the most direct and efficient route. Many routes cannot be flown at all. Etops, on the other hand, provides virtually unlimited possibilities. There have been more than 600,000 767 Etops flights since 1985. Of these 600,000 flights, 99.8% reached their destinations without turnback or diversion. The few problems that did occur were mostly related to systems, not engines. The same types of systems used on 3- and 4-engine airplanes, as well as twins.
When you address Etops, you not only address the engine reliability, you address the reliability of every critical, called Etops critical part. That's propulsion systems, that's electrical systems, that's pneumatic systems, that is air conditioning systems, that is hydraulic systems. And so you have to have sufficient redundancy and sufficient reliability to assure that the entire airplane as a system can get from A to B.
Airplanes are only part of the Etops success story. Operators who seek Etops approval must first demonstrate they have the necessary maintenance and flight planning expertise. The payoff is impressive. The twin-engine 767, for example, has achieved the schedule reliability exceeding that of 3- and 4-engine airplanes, thanks to Etops maintenance procedures and flight planning standards.
If people have got concerns over the reliability of the twin-engine operation, they just need to look at the statistics. There's been millions and millions of hours of Etops flying done, thousands and thousands of operations. In fact, there are 3 times as many 767 flights across the Atlantic operated by American carriers now as there are 747s. So a vast majority of North Atlantic flights now are in fact Etops operations.
Building upon a decade of successful Etops experience, a new generation of efficient twin-engine jetliners promises to extend these benefits to more and more passengers.
One of the things we've always tried to do is to design our airplanes to meet our customers' requirements. And in fact, even more important, to meet the needs of their customers, the flying public. And so what we've done is to take our experience and look at airline requirements and find that one of the things they have asked for is the capability to fly long ranges with smaller airplanes so they can provide better service to a lot more points. And what that did was define a long-range twin-engine airplane that could meet all of the airlines and the traveling public's needs. What we did was call on our experience building lots of airplanes, the efficiency of those airplanes, and design that into our new products so that right from the outset they had all of the capability and all of the reliability to fly these long-range Etops missions.
Boeing has drawn on everything the airlines have learned about reliability in designing the new generation of twin jets.
We went back and looked at all of our 30 million hours of successful long-range operation on all the Boeing fleet and came up with some specific things that we wanted to pay particular attention to. The engine is what everybody focuses on for an Etops airplane, but quite truthfully, the reliability of modern turbofan engines is so good that the engines aren't really a concern anymore. Certainly you have to have systems that operate reliably, and so really to focus on any one thing isn't the right thing to do. You focus on the whole airplane, make sure it's service ready, make sure it's reliable. There was really 2 things that we did to make sure that the airplane would meet the Etops goals. The first thing was to have a great plan, and the second thing was to have great people working on the plan.
Well, I think the 777 is if you like, another leap forward in the technology of the industry from the 757 to the 767 to the 777. There's nothing particularly new in many of the concepts. People know what they've got to do, they know how to go about it, and they've put the effort into the technology, the design and the testing that makes it a natural progression from the airplanes that we have of today. Just a very modern airplane that will be very, very reliable.
From unparalleled systems redundancy to the most comprehensive test programs in commercial airplane history, the new generation of airplanes, led by the 777, will earn a proven record of reliability before they enter regular service. And it is this reliability that will enable them to perform the Etops mission. Around the world, an Etops flight takes off every 5 minutes. And every 5 minutes, an airline and its passengers benefit from the efficiency, flexibility, and reliability of the modern twin-engine jetliner.
Do you have to make an investment? Yes, you do. You may have to change your flight planning strategies. You may have to have slightly more advanced flight planning computers in your dispatch function. Are you going to have to change your maintenance practices? Absolutely. Are you going to have to train your mechanics better? Absolutely. Are you going to have to give additional training to your pilots? Absolutely. You're going to have to. Those are investments. But the payoffs, they infect the entire culture. So you invest in a small portion of your operation, a rather modest cost, and your reward is the overall improvement of your entire operation, not just your Etops operation, your entire operation.
As we have sought always to improve our products, to make them better, to make them fly further, to make them more efficient, to serve people better, we have always tried to make them safer. In the last few years, all of those pieces have come together in a very unique way to provide a very long-range, very efficient, very safe twin-engine airplane that has the maximum amount of flexibility, can do every mission that is required, and do it with the ultimate safety.